the quotient rule. So very similar to the product rule, it's when we want to divide functions, we do it using a quotient rule. So objectives. By the end of the lesson, you should be able to recognize when you should use the quotient rule. Notice how it's italicized, should. We'll talk about that. And apply the quotient rule to find derivative and some final result. So again, it's when we're dividing two functions, right? So it's for a lot of people, it's a lot easier to tell a quotient rule than it is a product rule. But there's many times where you don't have to use a quotient rule. You can actually just do some algebra. So if f and g are differentiable functions, f over g is differentiable for all values such that g of x does not equal 0, this means that you don't want to divide by a 0 function. You get this formula here, right? So it's a little messy. It's the derivative of the top times the bottom minus switch it, derivative of the bottom times the top, all over the bottom squared. Now this one, it actually matters what comes first because you're subtracting. So you can't just go, oh, like it doesn't matter which one. You have to make sure you know which one's which. Luckily in IB we have the formula. So they give the formula right here. Again, don't get freaked out by the du dx thing, right? So if you have u over v, it's v times du dx, or derivative of u, minus u times derivative of v. I always remember, how do I remember this formula? Because it's very similar to a product rule, except for the fact that it's a minus and you're dividing by it. I always remember it's the derivative of the top first. So in my head I go, it's the derivative of the top. Derivative of the top, and then I know it gets multiplied by the bottom, and then minus, you just switch it. Right? So the key for me has always been derivative of the top. So that comes first. So I take the derivative of the top, and then times it by the bottom, minus, switch it all over the bottom squared. So keep in mind, just like product rule, don't be lazy. That's always happens when people get lazy, right? You don't just take the derivative of each one. It does not work that way. It doesn't work that way, right? So if you're taking, if it's a product quotient rule, to use this whole formula. So let's just get into it. If necessary, find derivative of each of the following using the quotient rule. So if you look at this first one here, right? Like, okay, if I was doing the formula, which is, I'll write it right here if we could use u over v. In our formula sheet, that would basically just be the derivative of the top, u prime, v minus, switch it, v times u times v prime, all over the bottom squared. Right? So if I was using this would be my u, this would be my v. It's a v. V. U is 1, u prime would be 0, v is x squared, v prime would be 2x. Bring it down, subtract 1 off. Right, so plugging into the formula, u prime, so 0, times v, which is x squared, minus u, which is 1 times v prime 2x, all over v squared. So x squared, squared. Well, look what happens. This goes away. 0 times anything is 0. This becomes negative 2x. Remember, you multiply powers here. X to the 4th. I could reduce that a little bit. Negative 2 over x cubed. And again, unless IB says otherwise, that's actually a fine answer, unless they specifically tell you to put in this form. But generally with quotient rule, they'll tell you to put in a certain form. So that's how you do the quotient rule. But let's go back to the fact that I said if necessary. Or how up here I said you should know how to use when to use the quotient rule. I actually don't use the quotient rule on this one. It is dividing. I could use it. I get the right answer. But if you notice, there's actually an easier way of doing this one. I could have just done this. These are our algebra skills. Flip it up. Now it's just a basic product rule. Power rule, sorry. Right? Bring the power down, subtract 1 off. I get negative 2x to the negative 3. Also known as x cubed. Right? So again, you want to make sure you know when to use I mean, you could always use a quotient rule when you're dividing, but sometimes it takes longer. If there's a shortcut, like, oh, I can just use some algebra, you probably want to do it that way. Now there's going to be some where you can't. You have to use a quotient rule, like the next couple, actually the next one. Right, look at this. I can't break it up, I can't do anything. This is just a quotient rule. So again, we can use the formula. Derivative of the top times the bottom minus switch it. Derivative of the bottom times the top, all over the bottom squared. That is in your formula sheet. So you can figure out what u and v is if you want to do it that way. That's totally fine. U would be x minus 1. U prime would just be 1 because that's 1. That goes away. V would be 2x plus 3. V prime would be 2. Then you can just plug it in. Right, but eventually you just get so used to it. You're just like, okay, u prime, so that's 1 times v, 2x plus 3, minus, flip it, derivative of the bottom is just 2, times the top, x minus 1, all over the bottom squared. So you get that. So again, if they don't specify, you could stop there. You are done. I will say, however, though, again, quotient rule, they generally want you to simplify. Now, they don't want you to simplify this. They'll generally have, like, your answer will look, they'll say, show me that it looks in this form or something. IB will say something to this effect. They'll probably use the C and the D there. But, like, something to that effect. You're like, oh, I gotta make it kind of like that. So that means we have to simplify. Right, so the 1 doesn't do anything. Distribute the -2 to both of them. Remember, it's a -2, so that matters. So 2x plus 3 minus 2x minus 2. We never have to simplify the bottom for the most part. It's like that. Here you can have like terms. Ooh, these canceled out. 3 minus 2 is 1. What? Math and joy, but don't look at me like that. There you go. Right, 1 over 2x plus 3 squared. So I guess this would have been like 1 over something like that. But that's how you use a quotient rule. A few more examples. This one, notice before you start doing the quotient rule, you could actually do some algebra. I could divide these. Remember, you have to separate them. You can't just cancel out the x's. So something to that effect. You reduce it all. This is x. This is 1, not 0. And then this one, remember, we'll rewrite it to the top, so it's plus x to the -1. And then from here, just take a derivative. Remember, that's just algebra. I haven't taken any derivative yet. Just the algebra is done. Just take a derivative. Derivative of that is just going to be the coefficient 1. Derivative of 1 goes away. And derivative of this one, you bring it down, subtract 1 off. -1 x to the -2. So 1 minus x to the -2. Again, you can leave it like that. If you want to make it simpler, you can. But you don't need to unless they ask. So again, you don't always have to do quotient rule. Algebra can help you. The next one, definitely have to use the quotient rule, right? So I can't separate this as u and v. We'll just do this one faster. Derivative of the top, so 4 times the bottom left alone, x squared plus 1. Minus, let's flip this, the derivative of the bottom, 2x. Times the top left alone, 4x minus 2. All over the bottom squared, x squared plus 1 squared. So again, as I always say, if they don't specifically ask you, you are done, you can stop there. If they do, if they say put in a form like this, then you could always distribute this, distribute all of this. So you get 4x squared plus 4 minus 8x squared plus 4x all over bottom. Then I could add, if you could read through my mess, you could add up like terms like these two. Negative 4x squared and then plus 4x plus 4 all over x squared plus 1 squared. Right, so that's the idea. Again, if they don't specifically tell you, you can leave it like this. A few more, and then we'll be done with this. So this top one here, right? Again, notice, can't do anything. So it's a quotient rule. Now this one, for our sake, I'm actually going to separate it. I'll do it the IB way since I give you the former sheet. So, right, it's the derivative of the top times the bottom minus the derivative of the bottom times the top. You just flip it all over the bottom squared. All right, the derivative of the top goes first. So let's separate it because there's something I want to show you here. So that's u is x minus 1. U prime equals 1. V is x e to the x. And then v prime, look at that. It's a product rule, right? It's x times e to the x. You're going to multiply these two. So don't just give me 1 e to the x. Product rule doesn't work away, right? If you're multiplying two functions, product rule. Product rule is the right derivative of the first times the second plus derivative of the second times the first. Right, it's the same thing at the top, it doesn't matter which comes first because it's the plus. But it's the derivative of the first, 1 times the second, plus derivative of the second, derivative of e to the x is easy, it's e to the x times the first. So that's what v prime is. Right, now that we have everything we need, we can put in the formula. Derivative of the top is 1 times v x e to the x, it's times. Minus derivative of the bottom, which is that e to the x plus e to the xx, times the top left alone, x minus 1, all over the bottom squared, x e to the x squared. And we'll just leave it like that. As a little review though, let me simplify the bottom to show you in case you were wondering. Right, that goes to both of them. If you simplify the bottom, you would get x squared e to the 2x. That's the way we write that. Right, ex squared is 2x. Okay, so again, let's do a few more. Look at this one here, right? Classic quotient rule. Right, we're gonna give you fx on the bottom to mess with you, but I think that actually makes it easier. Right, so let's do this a basic way. Take the root of the top, 3x squared, times the bottom left alone, so that's this f of x, minus derivative of the bottom, so you f prime of x, times the top left alone, all over bottom squared. Done, right? So they try to give you that to mess with you. I think this makes it easier. So okay, derivative of f is just, you don't think about it, it's just f prime of x. Okay, last one along the same lines. Find the derivative of f over g, that's f divided by g there, at x equals 4, and notice how they give you this box. So they tell you f of 4 is 2, f prime of 4. We're going to use that. So let's start off. So we know what the quotient rule is, right? Derivative of the top times bottom minus derivative of the bottom times the top, all over the bottom squared. Now all these we want at 4, so this is really like f prime of 4, g prime of 4. Well, f prime of 4 is negative 3. G of 4 is 5. G prime of 4 is negative 1. F of 4 is 2. Again, why am I doing 4? Because they tell me at x equals 4. And the bottom is this g prime, not g prime, this g of 4. So that's 5 squared. So I'm going to have this, negative 3 times 5 minus negative 1 times 2 all over 5 squared. So this would be negative 15. Negative 1 times 2 is a positive 2. So on the top I have negative 13. On the bottom I have 5 squared, which is 25. And that's the idea. And that's the quotient rule.